In the last two videos, we were talking about parabola. Parabola coming from the quadratic equation ax square plus bx plus c. In this lecture, I am going to speak about exactly how to plot a parabola. So we'll take specific examples. We will start with y equals x square plus 5x plus 4. How will this look like? How will this parabola look like on the coordinate plane? So we are going to analyze this quadratic equation. The first thing is, look at the coefficient of x square. The x square coefficient is 1 over here. So this is going to be an upward parabola because the coefficient is positive. The second thing that we are going to look for is the roots, and the third is the vertex or the minimum of this parabola. So let's start with the method of completion of the square. So we do 2 into 5 by 2 into x plus 5 by 2 whole square minus 5 by 2 whole square plus 4, which is x plus 5 by 2 whole square minus 25 by 4 plus 4, which is x plus 5 by 2 whole square minus 25 minus 16, that is 9. So, after completing the square, we get our quadratic equation of this form. So here the first we are going to find the roots or the zeros of this polynomial. The roots can be found out by just equating this to 0. That is x plus 5 by 2 whole square minus 9 by 4 equals 0. So x plus 5 by 2 whole square equals 9 by 4, x plus 5 by 2 equals plus or minus square root of 9 by 4, which is equal to plus or minus 3 by 2, and this gives us x, the two zeros, as minus 5 plus or minus 3 by 2, which is basically minus 5 plus 3, which is minus 2 by 2, minus 1, and minus 5 minus 3, minus 8 by 2, minus 4. So we have identified the two zeros of this polynomial. So if I plot 1, 2, 3, 4, 5, 6, it's minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. We have our zeros at minus 1 and minus 4. So the zeros are being taken care of. We know the coefficient is positive, so it's going to look like this. It's an upward parabola, and we are trying to plot it. So what comes next? The minimum or the vertex. The minimum value of this will occur only when this part is 0, because the square can never be negative. The minimum value of the square is 0, so we equate this to 0. So we have our minimum at minus 2.5. And what is the y coordinate of that? Of course, I have taken this to be 0, so this part will be 0. The y coordinate is minus 9 by 4, which is minus 2.25. So we have our y-axis minus 1, minus 2, minus 3. Minus 2.25 will be somewhere here, and minus 2.5 will be somewhere here. This is going to be the minimum or the vertex of the parabola. Once we have this, now our parabola is fixed. It's going to look upward. It has got two zeros. It has got a minimum. So parabola is going to look like this. Now we come to the second part. Now here we are lucky because we have got real roots, and it's analyzing this sort of parabola is much easier. What happens to those parabolas which doesn't have a real root? So we have to again repeat the same process. Of course, we have to change the parabola. It will be now 4 to 5. Same. Again, we will be completing the square. This x square plus 2 into 2 into x plus 4 minus 4 plus 5, which is x plus 2 whole square plus 1. Now we are going to do the analysis. Again, the coefficient is positive, so it's going to be an upward looking parabola. The general shape of the parabola is going to look like this. Now we come to the second part, the roots. For the roots, I equate this to 0, which gives me x plus 2 whole square equals minus 1. X plus 2 is plus or minus square root of minus 1, which, as we all know, is going to be an imaginary number. So x is minus 2 plus or minus I. Now this is an imaginary number. We will never find this point on the real x-axis, because x-axis, all these points are real. That's how we define the coordinate system. So the zeros will never ever touch this x-axis. Now you think about it. We have got an upward parabola which will never touch the x-axis. So it can never be here, because here if I draw it, there will always be a point where it will be cutting the x-axis. So it will have to be on the upper half. Now the question is, where on the upper half? So here we have concluded that the roots are imaginary, so it won't cut the x-axis. Now we are going to find the minimum of this. Again, the minimum of this is when the square is 0 So at x plus 2 equals 0, we have minimum. So x minimum is at minus 2. And what is the value of the corresponding y? Y minimum? This part is 0. So 1. So we have minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. And where do you have a minimum point at y equals 1 and x equals minus 2? So now we have got our parabola in the sense that we know it's not going to touch the x-axis because its minimum point is here, so it will just fly. So that gives our parabola which doesn't have a real loop, and hence it will never cut the x-axis. The other part, which is when this first criteria, coefficient of x square becomes negative, that is the parabola now looks downward. I leave it as an exercise for you to find a parabola which cuts the x-axis and which doesn't cut the x-axis, that is, just imaginary loops. I would like you to do this as a homework. That's all for today.